In this problem, we need to transform the Cartesian equation given by y raised to the power of 4 minus x raised to the power of 4 plus xy equals to 0 into its polar equivalent. So let us begin. First, we're going to use the fact that whenever we have the Cartesian coordinate x and y, the x can be represented in terms of its polar form as r cosine theta, and y can be represented as r times sine theta. So using these two ideas, we have to convert the given Cartesian equation to its polar equivalent. So we have now the equation y raised to the power of 4 minus x raised to the power of 4. We have plus xy, but what we'll do, we'll transpose positive xy to the right hand side to get negative xy. Now y raised to the power of 4 minus x raised to the power of 4, this can be also expressed as y squared whole squared minus x squared whole squared. What we have here is the difference of squares. That means this can be also expressed as y squared plus x squared multiplied to y squared minus x squared. So this will become equals to negative xy. Now what we'll do, we'll substitute the value of x and y with r cosine theta and r sine theta respectively. So y squared is going to become r squared sine squared theta plus x squared. So x squared will become r squared cosine squared theta. This will get multiplied to y squared minus x squared. So y squared will be r squared sine squared theta minus x squared. So x squared will be r squared cosine squared theta equals to negative. Now we have the product x and y. So we get r squared cosine theta times sine theta. Fine. Now here we can take r squared as the common factor. So this will get multiplied to sine squared theta plus cosine squared theta. Similarly, we can also take r squared common. This will get multiplied to sine squared theta minus cosine squared theta equals to negative r squared cosine theta times sine theta. Right. Now, we'll do one more adjustment here. We're going to take negative as the common factor here. So with negative times, now r squared times r squared is going to become r raised to the power of 4. This will get multiplied to sine squared theta plus cosine squared theta whole multiplied to cosine squared theta minus sine squared theta. That will be equals to negative r squared times cosine theta times sine theta. We can factor out negative r squared from both sides, and this will leave us with r squared multiplied to sine squared theta plus cosine squared theta multiplied to cosine squared theta minus sine squared theta equals to cosine theta times sine theta. Now we have two identities here. This is the first identity, which is sine squared theta plus cosine squared theta. We know that this value has a standard value of 1. And we have the other trig identity, cosine squared theta minus sine squared theta. So that's equals to cosine of 2 theta. Now we have one more identity here, cosine theta times sine theta. We know that whenever we have cosine 2 times cosine theta multiplied to sine theta, that this is actually sine of 2 theta. So in that case, we have a 2 missing here. That's fine. What we can do, we can multiply to cosine theta sine theta with 2, and 2 being an extra term, so we are going to multiply with half as well. Now let's use the identity. So we are going to get r squared times, so sine squared theta plus cosine theta will be 1, cosine squared theta minus sine squared theta, that gets replaced with cosine 2 theta. That will be equals to, now we have 2 times cosine theta times sine theta, so that's simply sine 2 theta multiplied to half. Let's rearrange it. So we get r squared equals to half times sine 2 theta divided by cosine 2 theta. Now this ratio, sine over cosine, that's nothing but the tangent function. So we have half tangent of 2 theta. But that means we now finally have our polar equivalent of the original equation. So that will be r squared equals to half tangent of 2 theta. So this is the final expression.